Greetings and welcome to my new calculus channel. My name is John Gabriel. In today's video we will be looking at propositions 17 through 20 of Euclid's Elements in Book 1. So let's begin. Now the first proposition states that for any triangle the sum of two angles taken together in any possible way is less than two right angles. And of course this proposition is proved during the prologue after parallel lines are defined. So there's really no need to actually state this again, because you can't have parallel lines unless you've already, in fact you can't have the fifth requirement unless you've already defined parallel lines and proved that the sum of the angles in a triangle are equal to two right angles, and therefore as a consequence the sum of any two will be less than two right angles. So proposition 18 says that in any triangle the greater side subtends the greater angle. In any triangle the greater side, so this is the greater side here, right? It's saying that this is the greatest angle. And of course again Euclid goes into a long drawn out proof. Well, it's proposition 19, and it's really unnecessary, because all one has to do is to just take a circle of fixed radius and position it over each of the vertices. So in this case we can see that the secant on which the angle is subtended is 3.73, and here it's just under 1, and here it's close to a half. So it's pretty obvious that the greater side will subtend the greater angle. And of course proposition 19 is the converse of proposition 18. Nothing to see or do there. It's not very hard to show, again using the same technique. And proposition 20, which is the final one, says that in any triangle the sum of any two sides taken together in any possible way is greater than the remaining side. So let's say that we take the sum of any of these two sides. This should be pretty obvious by requirement 1, isn't it? Because requirement 1 tells us that the shortest distance between any 2 points is a given straight line. So the only way that these two lines can be at least equal or shorter would be to lie on this line, okay, at least, because every other path that is not the shortest distance will mean that it's going to be longer than the path, the shortest path between the two green points. So if you take the sum of any two lines of a triangle using the one side as a base, as I've shown here, you'll see that there is simply nothing to prove there, because this is just one of the many paths, and you can construct any any triangle you like. It doesn't really matter, okay? It's just a different path, which is obviously going to be longer because this is the shortest path. That's all there is to that. So I hope you've enjoyed that little short presentation, and I will probably come back again in the not too distant future with more. My name's John Gabriel. This is New Calculus Channel. Until next time, goodbye.